Hello everybody. My name is Aaron Magnan. I will be doing today's live stream. Along with me, I have Brad answering questions. So if you're expecting to see Brad, I apologize. You'll have to watch me instead. But you can always talk to Brad in the comments there and pose questions to him related to his latest events. Before I get started in the generative design from MaRS subject matter, I wanted to make a couple quick announcements. First of all, I want to make sure everyone knows about Fusion Academy, and I'm just showing my screen real quick so you can get an idea of when and where this is and how to get to the website if you are so inclined, which we will pop into the description after this video, of course. Anyway, this is a great opportunity to get together with a lot of other Fusion users and to learn from each other. Brad will be there, I will be there, Lars will be there, lots of other great people will be there where you can get together and work and talk about Fusion 360 and learn more and more about it. So that's happening in August. So that's my first announcement. The other thing I want to announce is a very exciting 4-part series live stream that we're doing with Brad and Angelo together. It's going to include the whole design, programming, collaboration, simulation, potentially drawing creation and things like that in the 3rd episode where Brad will be showing that stuff. And then the 4th, we're actually going to be at the pier making the parts. So that 4-part series begins on May 21st. So go ahead and mark your calendars. I've started creating calendar invites, so it's hopefully easier to remember these events and to make sure to make it. So that does it for announcements. I'm sure I'm forgetting something. I do have notes again today, which is better than usual. So let's get into today's live stream. And what I wanted to do was I wanted to explain the name first of all. Today's live stream is called Generative Design from MaRS. And no, it's not the planet. It's actually our office in Toronto, Ontario, Canada. So you may or may not know this, but Autodesk was founded in San Rafael, California. Where I usually work is Pier 9 here. It's where we have a nice makerspace. But today I'm across the continent. I'm actually working out of the MaRS office, which is just it's a grouping of a lot of different startups, and Autodesk is included in that group. So we're not a startup, obviously, but it's a technology center where lots of great innovative things are happening, and actually we have another build space here as well. I'm actually in town for a sister-in-law's wedding, so what I wanted to talk about and why I wanted to do generative from here is because the office itself is actually really interesting in that it was designed with generative, and this isn't necessarily commercial code, but it's something that's really interesting, and I wanted to share a video that kind of explains how it was designed, and then we'll get into actually doing the generative design inside Fusion 360 in a context that hopefully is more pertinent to what you'll be doing. So sit tight, this video is only like 2 minutes long, and then I'll be right back and we'll get right into Fusion 360 and setting up a generative problem. So here goes.
In this project, which was using generative design to create the layout for an office space for Autodesk in Toronto, we actually started by figuring out what were the high-level aspirations for the space. We honed in on 6 separate goals for a good office layout. And these goals included things like trying to factor in all of the adjacency preferences of all 200 or 300 people in the space, trying to factor in the work style preferences of those same people, but then also trying to calculate some overall factors of the space, like the amount of daylight that came into the space, the views to the outside that were available. There are actually a few different physical features of the built space that kind of show the traces of the generative design process. One of them is that the grid of lighting fixtures for the space is oriented to show the areas of high activity. So if you look up at the ceiling, you can see that the lights are pointing in different directions, and that has been tuned so that those lights are all pointing to the spaces of high activity for this selected design. And that's one of the design goals for the space, to create a space with good activity and interconnectivity. Another physical feature of the space is the games room, which is literally painted with the different colors that come out of the daylight simulation from the space. When generative design can navigate a really large design space and create many, many design options, many more than a human could manually create, that gives us the possibility as humans with judgment and values and creativity to explore possibilities that wouldn't be possible otherwise.
Okay, so I hope that helps explain this office a little bit and how generative design can be used. Like I was saying, I think I mentioned this earlier in the intro, it's not really commercially available code at this point in terms of architecture, but it is actually inside of Fusion 360 already for what you're probably interested in, and that's design and mechanical design and things like that. So instead of looking at things like natural light and views and I forget the terms they were using in there, adjacency, preference, and things like that. Instead, we're looking at manufacturing method, and we're looking at material, and we're looking at strength, and all these things that are very important for your designs. So that's what we're going to be doing today, and what I'm actually going to be designing is actually an ice axe. So if you're into ice climbing, I figured this was a good fit for Canada since it's cold here, right? Although you wouldn't find many people ice climbing here in Toronto. It's not even that cold, to be totally honest, but these are really high performance products, and so what I'm going to be looking at is trying to redesign one of these with the generative design technology. So I'm just going to take a look at this and note some of the materials. I might come back because I might be using this to define some of the setup and to learn more about maybe an existing design. So at this point, let's go and just jump into Fusion 360, where I have started at just a basic ice axe design. Actually, I pulled this off of GrabCAD, I believe. So it's just used as like a base point of where we're starting from, and we're going to be able to pull off information from this to set up and learn about how we can refine this design with generative design technologies. So the first thing I would like to do before I go and I start, setting up a generative design is I want to vet this design as it currently stands. I mean, a lot of times your generative designs aren't going to be just starting from, square zero. You're going to start from maybe an existing design. You're going to want to refine it. So what I would like to do here is I'm going to go ahead and I'm going to just quickly change from my design workspace to my simulation workspace, and here I'm going to double check this study that I've already set up. I didn't want to spend a lot of time doing simulation setups and walking you through this because it's not really the subject that we're interested in, but it is something that we can use to learn about the performance of a design as it stands, right? So in this simulation model, I can look at some simplifications I might have done. So I'll just jump into the the simplification workspace, very similar to the edit model workspace inside of generative design. And so if I roll it back to the beginning, the first thing I did is I sketched a line here, and then I did a split face to split the area where someone might actually hold this, where that rubber handle is obviously located there, because that's going to help me define my simulation problem. From there, I went and I maybe removed some items, like I removed the handle. I'm not concerned with the handle failing in any way, shape, or form, so we can just get rid of that for my finite element analysis sake. I removed the bottom claw. Maybe I'm really focused on how the top part of this performs. I mean, at the end of the day, we're concerned with how the whole thing performs, but maybe for the sake of the simulation, I want to just focus in on where the highest loads will be. And we'll come back to that. That's an important thing to consider as we move forward. And then I actually went through and I removed some of the hardware, so I'll just skip a couple of those because you don't typically want your hardware to be showing in a simulation. You want to just get rid of those and use, setups inside of the simulation to represent them instead. And then from there, we went and split it one more time. I realized that I needed just an area that more closely resembled where the person would be holding this. I didn't want them holding all the way to the bottom of this ice axe. So that's what I did to prepare this model for the simulation's sake. If we go and look at the study materials, and this is something that I pulled from the information that I saw on that Black Diamond website, maker of some amazing, climbing equipment and various other things. But I tried to align with what I saw them saying that they use, and obviously they didn't get into specifics like what aluminum alloy they use, but for extruded aluminum, I think a 6061 is fairly common, at least in my short amount of research that I did on that. They mentioned chromoly steels, so that's a 4130, and I think I actually forgot to define the head itself as being a different steel type, so it's just this basic, boring steel that really has no more details on it. Just kind of like a generic steel representation. So from there, I went and I set up the load cases. So this is a very similar thing that we'll be doing inside of Generative Design, and we're going to actually pull from this to reuse it. So, maybe the biggest known load is like a 350-pound load on the main pick of this ice axe. And the way I came to that number is I'm thinking about an average user, but also all their equipment as well. That's going to add a bit of weight to this, so I bumped it up to 350 pounds. And then in addition to that, there might be loads acting from the side from time to time. It's never going to be just, one single load acting perfectly normal to a face. There's going to be all kinds of different loads that you need to consider. So left and right. And then, maybe there's a force on the back end of this that we want to consider as well. So we put a force on the back end. And I'm doing these all as separate load cases because each load case is, acting separate from one another. They're not acting on this at the same time. Obviously, if there were cases where it was acting at the same time, you could apply more than one load. And for each one of those load cases, I fixed that handle area again, just to represent where someone's actually holding on to this thing, right? So then I went and I solved it, and again, another one of these things where I don't want to spend a lot of time solving things in simulation, because again, its main focus here is generative. So here's the results from load case 1, here's some results from load case 2, and you might notice some concerns here, like the safety factor for some of these is under 1, which is representing failure, and real quick indication to that is this red exclamation mark inside of this dialog in the lower right hand side here. So there's some concerns there. Also this small load on the back, which doesn't seem to put it under any stress, any considerable stress I should say. So we can go and we can look at these, and typically what you're really concerned with is maybe the load case that causes the lowest factor of safety, and maybe we could use that to try to refine the design, because then we know which case is causing us the most problems, and then we can take that and use that in a future simulation as we refine the design. However, what I want you to note and what I want you to understand is that maybe some of these aren't really accurate. Maybe they're not 100% accurate, and the reason for that is what are called singularities. I'm not going to really get into it in fine detail today, but I do want to note that this is something that is inherent to all finite element analysis. This is in whatever tool that you might have used that solves a problem in this way. If you have these sharp edges, stresses can go crazy. They can go off the charts. Basically, the smaller you make the elements, the higher the stress will go, and that will represent an area where a singularity is. Now, you can work past that if you're certain that you have a singularity. Essentially, what you can do is take a look at the mesh and try to understand, what the stress is one or two elements away from that location, and that's going to be more accurate. And obviously this mesh, and I just showed it here by clicking the little hide show right there, this mesh isn't all that fine, so I'd actually want to refine it to really understand if there is a singularity happening there. But it's something to consider, something to think about, and something that we can take with a grain of salt when we're looking at some of these results. So, if I wanted to, skip past some of these very high stresses that might be caused by singularities, I could go and I could double click on the scale itself. This gives me the ability to kind of rescale it in a way that helps me visualize these results a little bit better. Maybe I'll go to like 35 KSI, and it's starting to become more obvious to me that yeah, there's potential for a singularity happening there. Now, what I need to explain, and I didn't really cover it in my last simulation that I did, is, sorry, I was looking at the comments and it sounds like there's voices. I don't think there's anyone in the background here, hopefully. So what I wanted to talk about is where this factor of safety actually comes from. So if we look at this and we go and we want to look at these results a little bit closer, we can go and we can turn on like show min-max. This is going to help us visualize where these stresses are. So what I want you to note is it's 45 KSI in this top piece here. That's where the highest stresses are happening. And if we go and we look at the study materials, and again recall that the safety factor for this, the minimum safety factor is about 2/3. What I want you to note is the study material that was used for that headpiece. So if we look at this headpiece, and then we go and we look at the properties of it by clicking this button here, we can see the yield strength is 30 KSI. So by going to 45 KSI, obviously I'm yielding, and that's a big problem. That's something we'd want to consider, and that's where that number, that 2/3 comes from. 15K basically over that is gonna be somewhere in the range of 2/3 of factor of safety. So we're considering that this yields. So with that in mind, let's see how we can redesign this to make it stronger, and maybe try different materials to make it stronger. So what I did here actually in finite element analysis was I tried different materials, right? This is a real quick and easy way to try to increase the strength of your part. So the next thing I did was, I went and I changed the material for that headpiece. So instead of, in this case, being that generic steel, I made it 6061 aluminum for the head. And in this case, I didn't change the model material. I changed it within the study. And that did give me some improvement in the load case, which I'll come back and review in a second. And then I did it with all 6061 aluminum, and then I did it all with that chromoly steel. So we have 4 different results here, and looking at them all individually, it's very hard to obviously gain information from it. So the easiest way to get information from this is to control select all 4 of them from the browser over here on the left hand side, and we'll select compare. And what this does is it gives us 4 different side-by-side views of this, and it's synchronizing the view. We can synchronize the result type. We can synchronize the min-max to really help us visualize which one might have the worst or best scenarios. But we can also, in each one of these, look at the different load cases. So what I want to make sure to do here is be looking at load case 1 for all 4 of these, and I'm just verifying it by selecting in each one of these different windows. Now, the one that seems to be giving me the best results is this one in the lower right-hand side. This is actually the one that's all chromoly steel. This is the case where the minimum factor of safety is 2.5, which is making me feel much safer about this design. So we made an improvement on that. However, there's other drawbacks to using a different material. It could be added weight, obviously, right? So what we can do here, and let me do something here. Let me change the stress to the stress display. And actually, one thing I would always love to do is I like to synchronize my result type. And then when I change this to stress, it's going to show all the stresses across all these different guys. And this is a real quick way to get in and really compare and contrast between the 4 different designs. And you could also clone the simulation model, make changes in the simplify setup, and then compare there as well. So if you're trying different design shapes, if you're trying adding gussets or strengtheners, strengthening methods or thickening things, and there's all kinds of different design choices you can do, and all this can be compared in this compare workspace. So we're pretty happy with that. We've made an improvement just by changing some materials, but let's see how we can really improve this and push it to the next level with some generative design, right? So what I'm going to do is I'm just going to jump from my simulation workspace over to my generative design workspace, and I'm going to start to consider, how we're going to set this up and what we're going to need to do to get to, a fully optimized version of this. So just did a double-click mouse wheel there to do a zoom to fit, and I'll do it again real quick. And in looking at this, and actually let me do one other thing real quick. I want to jump to the design, and I want to note that this design has actually some motion to it. Obviously, this folds up. Maybe for when you're not using it, you don't want sharp edges pointing out. This thing folds down, and those are things that you could potentially aren't a requirement of the design, but obviously it's a nice feature to have. But when I go to do the generative design on this, I'm going to assume that we're going to have it fixed. We're not going to want to fold it up anymore. We're not going to need to make it compact. There's only one time I need my ice axe. It's when I'm climbing ice walls. I don't know, but we're going to assume it's just going to be open all the time. And what's neat about that is that it's going to enable me to make this all from one single part. And this is I'm going to look at producing this with an additive method, so we can try that. We can make it all stationary, and we can do a number of different other things too. So let's rotate around and let's start to prepare this model for this generative study. And so very, very similar to the simulation setup, we're going to basically just work our way from the left and go right. So we already have a study set up, and basically when you jump into the generative workspace, you have a study set up automatically. So it's not ready to run right now. I need to define very specific regions of this model for things like what are called preserve regions and things like obstacles, which are just like they sound. And if you have questions about what they are, look at the tooltips. Obstacles represent areas that need to be avoided. In this case, it could be where someone's hand needs to go around the handle, or you want to preserve or make obstacles around the shape of this pick, because maybe it's designed in that way for a very specific reason. Maybe that was found to be the best way at gripping onto the ice. So maybe we can make an obstacle around this so that we don't alter the shape of that, right? So it doesn't have a support coming off the front edge of this or the back edge of it, right? So we're going to jump into the Edit Model dialog, and this is where we're going to get into setting this up. And so it's relatively simple here. And what I'm going to do is I'm going to want to define areas to preserve and to define areas to basically get rid of, right? So the first thing I will do is maybe I know that I'm not going to need the bolts, right? So I can double click a bolt, and I can right click and I can select to remove it. I can undo it again and remove that completely. And there's two more on the bottom here, and I can control select while double clicking to repeat that remove to get rid of those altogether. The other thing is that in terms of this generative design, the handle is going to remain fairly consistent. I actually want to preserve the current shape that it is right now. So I'm going to assume the handle is not going to change at all. The design is not actually going to need to be altered in any way for this generative design. So I'm going to right click and I'm going to remove that as well. And then I want to start to split a region from the existing handle in which I'll use to define a preserve area, right? So I'll create a sketch, and I'm just looking for a flat face. I could use the plane that's here. I could use the face on the front of this back piece there. And on this, I'm going to do maybe just some real simple lines. Like I'm going to draw a line across here, and I'll draw a line across here, and then I'm going to use a command that I use all the time in simulation and as well in generative. I'm going to use a split body, and what this is going to do is it's going to take the body that I select, and I'm going to split it into different pieces. I'm going to use my sketch, obviously, the line there to split off the first piece, and my sketch goes away, and I can't select multiple right now. think there might be something coming that's going to enable us to reuse that. But right now I have a body here and I have a body there, but I want to get rid of the bottom part of this as well. So again, I'll just right click and I'll use my mouse gestures to get into that repeat split body since I want to reuse it, right? So I'll select the body, and this time it's that bottom piece, and I'll use that to split that. So there we go. We'll hide that sketch, and we can select this body. To remove bodies, I find it kind of difficult because when I double click that, it wants to get the whole component, right? So to remove both this body and this body, I'm going to do something else. I'm going to actually find those in the browser here, and I'm going to expand the group, and I'm going to find the two that represent the ones that I want to get rid of, that I want Generative Design to fill that area and figure out new ways of creating the shaft. So I'll just select the two bodies and remove them from that dialog instead. I'm going to most likely want to preserve this back piece. Like I say, I'm not like an expert with ice climbing and ice climbing pick designs, but I assume it's that particular shape for very real reason. It's probably been found to be handy for these guys that do these extreme sports. Now, I also want to get rid of the piece on the top here, this head, because like I say, I want to basically create one single body that connects all these to make it a stationary pick instead of the foldable type. So in this case, I can just double click and right click and remove that. Now, when we get into looking at these guys, it's kind of questionable about what portion of it do I want to keep, which portion do I want to remove. Like the top edge here, like maybe that's unnecessary. Maybe I can trim some of the material away from that to make it a little bit lighter. All kinds of different stuff that we could do there. But I'm going to zoom in, and I'm going to first just delete the holes outright. So I'm just going to select the hole itself and hit delete. That's going to add a delete face feature. I absolutely love that Fusion does that for us. And then, assuming that Generative is going to fill this up with a very, optimized shape, I'm going to do one thing here. I'm going to insert a sketch, and maybe I'll just trim a little bit off of maybe the top piece here. And I'm not necessarily saying that this is how I want it to be in the end, but this is just something that I want to consider to get rid of. Obviously, if Generative finds that it needs more material there for support, then it's going to be able to add that material. So I just drew that sketch, hit the E key on my keyboard to jump into my extrude to cut away a little bit of material, and there we go. We just shaved a little bit off the top there. I could do the same with the hammer on the back, but I don't want to focus on that too much because I also want to obviously create some of these obstacles, right? And as mentioned, I want to essentially keep these as preserves as they currently lie, keep this as a preserve and keep this as a preserve, but I don't want a bunch of additional material coming in on the front and back end here, because those are obviously that shape for a very particular reason, so it can grip the ice, right? So what I'm going to do here is I'm going to create basically an obstacle around these current shapes. So I'm going to create a sketch, and again I can use any flat face to begin sketching on, or the planes here at the bottom. And we'll look normal to this, and I'm going to start projecting pieces off. So I'm going to hit P on my keyboard, and to project these off very quickly, I'll just select this guy, and this guy, and there we go. We've created some sketches that I can use to kind of define these regions. So the next thing I want to do is I want to create just like a general shape around the outside of this. So I'll just draw some splines there. Draw some splines up here. And again, I want to kind of confine this somewhat, so I'm going to just kind of cinch in here slightly. And that's created one region that I can use to start to begin to create some obstacles. On the top here, I'm going to do something similar. I'm just going to kind of fold this around. And I'm being really willy-nilly with this sketch. There's other things I could probably do to make it much better, but with the time that we have to do these presentations, I'm going to try to just cut it as quick as possible. So there's one more opening here, so I need to also consider how I want this to close off at the top here, and I'll just draw a quick straight line between these two guys. So now I can start to extrude out these obstacle regions, and I'm going to just pull this face up, and I'm going to pull the back end, and instead of doing a cut, obviously, I want to create a new body here. And instead of doing one side, I'm going to do symmetric. So right now we're just defining basically a region to avoid adding materials. And like I say, I'm making it real close around some of these pieces. And I'm kind of cutting into that guy. I can fix that a little bit later. But there we go. We've created some nice kind of obstacle regions. So now I'm essentially going to try to drive the handle into this middle section here. So it's going to start to fill in this middle section, right? The other thing I want to do is I want to create an obstacle around the handle, right? That's because the person who's going to be operating this thing is going to need somewhere to hold on to. So I'm going to do with a surface offset. I'm going to offset this at basically 0 inches, and then I'm going to use a thicken command, and I'm going to use my S key to jump into that thicken command very quickly, and then I'll pull this up and out to make this another region to avoid essentially. So that's a real quick and dirty intro to the obstacle and preserve creation. But these are all things that you'll need to consider as you go to set these design studies up, these generative design studies up. So at this point, then I can start to define things like preserves and obstacles, and I'm going to just start with my obstacles. I usually like to start with my obstacles because once I've selected the 2 items basically that I'm going to be defining here, I can go and I can hide those. And this is handy because basically everything that's left is typically something that you want to preserve, right? So I'm going to select the remaining bodies here, and I'm going to set those as preserved geometries. And by being preserved geometries, obviously they're gonna be there at the end of this design study, which is very important. But I'm also going to make sure that whatever happens in the middle here is going to be confined to where this obstacle geometry has actually been laid out. So just like that, we've started to set this up. Now we also are going to consider the loading conditions acting on this. So I'm going to go and I'm going to start to define these structural constraints. So I'm going to select the constraint first of all, and as mentioned, the handles where this is being held, it's where it's being fixed. So I just hit C on my keyboard, and I'm going to apply fixed constraints to the outside of that handle. And then I'm going to start to define the structural loads. And I want to align to what I was using before so that we're looking at this apples to apples. And I'll select that face right there. And this force, the one that I had previously defined, is acting normal to it, so I don't really have to play with direction or anything here. But I'm going to set this at 350 pounds, as mentioned. That was kind of like what I found to be the worst case scenario, right? That's the climber and all his gear and all kinds of stuff is going on there. So that's one load case, and after learning from my simulation, I'm trying to switch to show my face real quick, but it's not going. Sorry. So after what I learned from the finite element analysis, you might think, maybe I'll just take the worst case scenario from the simulation and use that to define my generative design study. And that's something that you definitely want to avoid doing. In the generative studies, you want to consider every single little load case you possibly can. If you only define like a single load case, it's going to just find the most direct path. It's going to be kind of boring. The results are going to look bad, and they're not going to really encompass everything that you're going to need to consider for the generative design study. So in addition to this, the worst case scenario, I'm going to add all the different small load cases that are going to happen to this. So I'm going to clone load case 2, and I'm going to clone load case 1, and in load case 2, I can go and I can edit or delete the load that was currently there, add a new load, and I jump to this by hitting the L key on my keyboard. And in this case, this was just like a very similar amount of weight, but in this event, I wanted to kind of offset it somewhat. So I offset this 30 degrees. Obviously with this design, it's going to it's not always going to happen one direction, so I'm going to clone that load case, and in load case 3 I can get in and I can just flip the direction maybe, right? So I can come in here, it's the same setup as before, so I'm just going to make this 60 degrees. That's, previously it was 30, so I'm just flipping it to the opposite side. So now we have load case 2, load case 3, the normal load case, and then I can start to apply other load cases as well. So I can clone and copy and apply new loads, right? So all important stuff. I hate to skip past details like that for the sake of getting to all the material, but do not overlook all the load cases in your design. Do not think you just need to encompass the worst load case. You need to consider everything. You need to consider, the 10 pounds that are going to act on the bottom of this piece. You need to consider the 50 pounds that'll happen on the back face here. You need to consider if you drop it, or if it's like being pushed on at the top here. You want to consider every little load case possible, right? This is going to give you the best potential generative design results. So once you've gone through that and you've defined all that, we're going to get into those objectives, and this is probably the easiest thing to talk about in generative design. It's do you want to minimize the mass, or do you want to maximize the stiffness? For minimizing mass for a product like this, maybe safety factor of 2 is good. Maybe I want to just match what I was doing with my other design. Maybe I'll go to 2.5, or maybe I can make it really high performance, go to like 1.5 or something. But if someone's life is on the line, I want to make sure that this is going to be very, very safe. And then once that's defined, you get into your manufacturing criteria. So very important to pay attention to this. There's the unrestricted, so this is just going to make the best shape possible. And some people use this to help drive their design shapes going forward. I have additive turned on here. Depending on the machine you're using, overhang angles are going to affect the number of supports required, so you can make changes to this here. You have your minimum thicknesses to consider as well when you're using additive approaches, as well as the milling constraints. So we have 3-axis and 5-axis and all kinds of other things that we get into. And currently right now in preview is this 2-axis cutting. This problem isn't really set up the way it is right now to do 2-axis cutting. Obviously, with 2-axis cutting, you want everything to basically be the same thickness. You don't want loads acting in crazy directions and things like that. So, I might toggle it on here. I'm not actually going to be solving this. These things take a very considerable amount of time to solve. So I'm going to just, I'll turn it on here, but do know that this really isn't set up properly for a 2-axis study. It's pretty close. If the handle were, same thickness and in the same plane as this piece as well as the hammer, then there's a potential for a 2-axis cutting option, right? From there we get into the materials, and so depending on if it's going to be milled or if it's going to be additively manufactured, then we can get in here. We can start to add materials, and I'm going to just grab like a generic aluminum. And to add it, you just click and drag it into the study at the top there. And with additive, I can get into all kinds of materials. I'll do this titanium 6.4. We had mentioned the chromoly, so I'll grab this 4130. All kinds of different materials, and I think you got up to is it 7 or 10? I think they just changed it not too long ago. I'm going to click and drag a couple of these. There you go. That's the maximum. 7 is the maximum at the moment. So we've defined 7 different materials here, and then before you go do anything, 100% check this pre-check. This pre-check is going to tell you what's wrong with why you don't want to use 2-axis cutting with the way that it's set up. So this is telling me, hey, you've not set this up properly for 2-axis cutting, and milling, it's even giving me some nudging me in the right direction, saying, hey, that head diameter is large compared to the model size. And let's go ahead and review those, right? So let's jump back into manufacturing, and I'm going to turn off 2-axis cutting. And for the 3-axis, the minimum tool diameter of 3/8 is massive. What you're considering here with this minimum tool diameter is, finishing pass, like getting into all the little nooks and crannies and getting into every little pocket. So, 3/8 is giant. So let's go to something a little bit smaller. Let's go to like 2 or something. I'm just kind of picking one at random. I think Angelo's in the audience right now, and he's someone who knows a lot more about machining and CAM than me, so that's probably not even a size that exists, or I mean, probably is. There's all kinds of tools available, but I'm going to just select that, and then let's go back and double check this, and it's still telling me there's something to consider there, but I'm going to just skip past that. Now, at the end of the day, I do want to 100% run this previewer. This previewer is going to help steer you in the right direction, let you know if you've set something up wrong, or if there's ways that you should refine or consider changing the way that you've set it up. So start this up. It's going to, in hopefully a short amount of time here, we're going to start to see like a general shape of what this is going to look like. I'd recommend you let this run for a little bit of time so that you can start to see these shapes. And it's not happening quite as fast as I'd like it. And so there we go. It's starting to preview here. And I was not liking the look of that piece out there to the right. And the other thing I'm not really liking about it currently is maybe some of how thick it's getting around here. So, that previewer failing is something to consider. But you notice it was actually adding a lot of material to the outside of this, and that's something that I could go back to edit model for. And I didn't consider that I also want to kind of preserve the thickness of this. So that's another thing where I could do like a real quick surface offset to both sides of this, and then thicken those very quicker. And now it's going to avoid, adding material to the side of that, right? So actually, it's not going to avoid it right now. First, I need to define that as obstacle geometry, and that's going to help avoid those areas. So I can go back into previewing, and hopefully that's been cleared up and the issue's been resolved. But at the end of the day, when you're ready to solve, click this button. It's going to send it off to the cloud. It's going to give you your results back in some amount of time. It's 25 cloud credits to start to see these generative results. What I will say is today I was trying to get results back very fast. I wanted to create some different scenarios and run some different manufacturing methods on this. If you hit E on your keyboard, and I actually did this on accident earlier, but if you hit E on your keyboard, usually you go to extrude, but because we're in generative design, it's actually taking us to our synthesis setting. So to get results very fast, you could slide this to the left. If you want very fine results that take a very long time, you can slide this all the way to the right. I would recommend, if you're going to be using the synthesis tool, that you make small changes. You don't just jump all the way one way or the other. It does a very good job just by default at refining the design per the geometry that you've used. So that's something to definitely consider, but don't overdo it there, or else you're going to be waiting for a very long time potentially for your results, or you're going to get very coarse, bad results. Okay, so with that, I want to show you some of these different studies that I had set up. So basically, this first one here is the same setup. I just kind of had a little more time to refine some of the preserve and obstacle regions, and so this is a little bit of an iterative process. Like I'll create one study, I might take the results and I'll use that to kind of refine my obstacles or preserves, or maybe I'll thicken something or shorten something. There's all kinds of different things you could do there. But in the next study, I started to use a starting shape. I wanted to try to kind of guide it to a certain shape that I was after. So that's this yellow shape that you see here in the study 2 setup. In study 3, I think what I started to realize is that by including the bulk of that hammer, it added a lot of weight, and potentially we could have removed that. So I actually went and I split that body out, and I started to kind of cut away and kind of just whittle away to the areas that are just totally required. And I think I also made changes on the back hook here as well. Model 4, again, just some small refinements. Model 5. This is where I was actually, generative design is not all about making impossible to manufacture parts. It's also about making potentially, much cheaper parts. Like there's a potential that you could make something like this with 2-axis, right? I mean, it's not quite going to fit in your hand the same. It's not gonna have stiffness into plane, but it's a potential way to make this. Maybe you want to be able to make these cheaply for whatever reason. So in this case, this one's actually set up properly for 2-axis setup. So you can see that they're all kind of in the same plane. I've gotten rid of the thickness in the hammer there. I've kind of set it up in a way that's now going to enable me to actually get some 2-axis results from this. And then finally, in the 6th one, I was taking that, I was kind of refining it more. As you'll notice, between Model 5 and Model 6, I realized that maybe this is a little too constrictive for the 2-axis setup, so I made it a little bit wider in terms of where the material could go, right? So all kinds of results to go through here. Once you have your results back, you jump into the Explore workspace, and this is going to take a second to bring these results over for us. I have a number of different studies there, and some of the results I don't like at all. Like the first one I set up, I did not leave enough, I didn't make the obstacles big enough. So you notice these big giant massive pieces, those are not final picks, those are not going to make the final cut. So if you notice that all study 1 missed the mark, I can clear that option from the study selector here on the left to kind of filter through the results. If you also notice maybe like study 4 here has kind of a similar problem, we can clear those. And then we're starting to get into some nice looking results. One thing I definitely want to consider is the mass, right? And because I'm looking at 5 different materials here, this is something that I'm not going to know the final mass just by looking at kind of the shape. There's different densities involved, obviously. But what I do know is that I want this thing to be like the same weight as it is currently or lighter, right? And as it's designed right now, it's like 2 pounds. So maybe I'll just grab this slider and I'll just drag it to the left until we kind of filter past all this other stuff, and I won't get quite to 2 pounds. But here we're starting to kind of get to the results that are potential solutions to this problem, right? So I've kind of filtered through there. In addition to using the filtering on the left and kind of visualizing what's happening in some of these, like this guy's kind of interesting, right? So to learn more about how this was set up or why it got to this shape, you can look at what material is being used, 7075. The orientation and manufacturing method, this is unrestricted, obviously. I mean, I can't see this being printed very easily, and I can't see this being milled. Unless you have a lot of time and a lot of patience and you're a fantastic programmer like Angelo. But there's a lot of things to consider when looking at these results, and you're not just going to take this and go straight to manufacturing. There's actually a lot of refinements that you might want to make just to doing something here will. There's a lot of refinements you can make after the fact, and I'll show you some of these finished products in just a moment here. But another way you can explore here is to look at the scatter plot. This is probably my favorite way, and this guy's kind of thrown off the scale, but fortunately we can actually just draw a box over the area that we're most interested in. For what we're looking at here, factor of safety 2 pounds. I'm mostly interested in what's down here in the lower left, maybe. So I'll just draw a box around this region, and now we're kind of filtering to the ones that are most interested. Now, I've already exported a couple of these, so I can also do things like isolate the ones that were created from the outcome. So I created one from the 2-axis, I created one from this unrestricted option. I'm going to reset the zoom because there's another one up here, and there's another one way out here as well. But I've exported a couple of these, and we can go and take a look at those results in just a minute here. So I'm going to just go and jump into my data panel. And what I wanted to show you is that, hopefully everyone knows this, but I'm going to grab this guy. This is an additively manufactured one, additively manufactured in the Y+ direction. That's just, I gave it that name to help me remember how it was created. But right away we can start to look at these results. One thing I want to note is the factor of safety is not 0.86. Safety factor is 2 for this. This is one of those cases where you might have some some singularity that's skewing these results. So what's great about these exported results is that all the load cases will come over from Generative Design. In addition, the study material will come over from Generative Design. So this is the titanium 6.4. Most likely going to win, obviously, if we're just ignoring cost and other details. But we're starting to see a lot of these results, and what's great about these is that you can actually come in and start to make changes to it, right? Like, for instance, this guy is pretty ugly in the way that it goes from this very small connection to this piece, and this was one of my earlier iterations where I just kept the hammer kind of as is. But what's great about this is I can go in and I can make a quick change to maybe the sculpted body here. One thing to note is that the sculpted bodies will be frozen at the interfaces. So if you wanted to make a change to the way it is currently created, so I can come in here and I can unfreeze, and there it is. I was about to use my S key to search for it, but I'm going to just select those faces. So now I'm actually able to use my edit form, and I can make this transition much smoother than it currently is, right? So I could grab this, and actually I probably just want to select a couple pieces here and slide them up. But there's a lot of refinement that we could do inside of this sculpt workspace to kind of make this transition smoother. Obviously, we can go and cut away from the other piece as well. This is a really quick and dirty attempt to do this, and obviously I am not the best person at sculpting. Where's Jamie Shearer when you need him? Anyway, as you can see, there's quite a lot of editing capabilities, and this is, if you do go and make edits to it, this is why that bringing over the simulation data is so hugely important. That's because, after I make this quick sculpting change, I can go right back into the simulation workspace and I can double check to make sure that what the change I did there is not going to really affect the final results. So I think that does it for, and as I jump over to the simulation workspace, it's showing me, oh, I actually did make a change there before I actually made the change inside the Simplify workspace. So I went into Simplify and I added a loft between those two pieces to try to make that transition easier. So you don't have to use all sculpting tools like I was struggling to do there. I'm a little bit more capable with some of the more traditional features, but in this case I actually created a loft to connect those two pieces. Still needs a lot of work, but gives you an idea of how you can edit that and then resolve it to vet to make sure it's still going to meet all your design criteria, all your factor safety requirements and such. So I think that, sorry for yelling at you there. Having trouble switching with my keyboard shortcut. So I think that does it for what I wanted to show you today. I hope that was valuable. I just really wanted to give you an idea of how you can use generative design, and more than just how to use it, but like how to get to considering where you start from. You don't just jump straight into generative design. I think it's good to like run a simulation to get a baseline, to understand where you're starting from, to think about your loads and constraints, and then from there you start to bring that over to generative design to run through all the different studies and to create these very unique looking results. So I hope that helped. Checking off from MaRS. Thanks for coming out today. Cheers.